So what's the challenge with improving football helmets with regards to concussion prevention? Well, first we have to understand the two major types of impacts. One is called direct or linear, and that's where the helmets come together in a straight line and collide. And the other one is called rotational or shear impact. And that takes place when the helmets hit each other at an angle. And what happens in that rotational impact case is the helmet starts spinning, the skull starts spinning, but the brain takes a while to catch up and it's rotating within the skull. Causes a lot of TBI brain damage. So that's the most serious impact that you can experience with regards to concussion. So most helmets have foam liners in them. And the big problem with the helmet liner foams is they handle the straight or the linear direct impacts okay, but they can't rotate. So if I try to rotate this or shear it, it's just not budging. So what if you had a helmet liner that handles both types of impact well? This is fiber energy absorbing material, otherwise known as FEAM. So as you can see, there's thousands of nylon fibers that absorb. It's like a fiber sandwich. It absorbs the direct and rotational impact. So we can make it into multiple layers like this, or single layers. We can vary the fiber diameter or length or density. So let me show you how FEAM kind of works with a simplified little toy here. You can hit FEAM direct and it handles direct impact well. But what the special advantage of FEAM is that when you hit it in a rotational or shear direction, the fibers bend and they redirect that energy away from the brain. So you're protecting the brain by kind of disengaging the helmet shell, so the force is kind of redirected away from the person's brain. So my name is Bill Linden. I'm co-founder and president of Corsair Innovations, and we've been developing FEAM for the past 5 years now. It was invented at the University of Massachusetts, Dartmouth, and in 2015 we were awarded a Head Health Challenge semi-finalist grant, and with that grant we developed FEAM into a material that could be used in headgear protections, helmet, head foam. This animation shows you how FEAM is made. So we take a fabric, apply some flock adhesive, and then we drive fibers into the fabric using what's called electrostatic process. Then we put another layer on top, and that's like a fiber sandwich. So that shows you how the material reacts when it's directly impacted, and now we'll show you how it reacts when it's rotationally impacted. So how can FEAM help in a helmet? And we did this other little animation here I'll show you. So here's an animation of a football helmet getting hit. The helmet moves, the skull moves, and then the brain takes a while to catch up. Now we take FEAM, and the FEAM helmet, the fibers bend and they redirect the energy so that the player is more safely protected. In 2015, the NFL awarded us with a Head Health Challenge 3 semi-finalist grant, and with that money we took those funds and developed FEAM into a material that could be used in helmets and also body padding. In 2018 we won a Head Health Tech 4 grant, and we took those funds and we actually put FEAM into a helmet. Now what we did was we took this Zenith Shadow helmet here. This is a stock Zenith helmet, as you can see. And we bought another one. We took all the helmet liner materials out and we replaced it with FEAM. So you can see we just copied the footprint of the helmet liner and those circular pads right there. And then we put it through NFL protocol testing and biokinetics. And the results were that we improved both direct impact handling and also rotational impact handling in almost every spot they tested on that helmet, the FEAM helmet. So with NFL funding, we will produce comfort pads, fit pads, that will go into any helmet maker's helmet, any company that wants samples.